Hey ladies and gents, welcome to another day in biology. Today we're going to talk about 8.4 and this is transcription. Now usually when we do testing and we do like essay questions, we'll usually talk about transcription and translation together, but because they are intense sections, I broke it up for you. But a lot of times like this will probably be a really good essay question. Talk about translation or transcription and translation. You have to talk about them together, but just so you know, I broke them up just for simplicity, okay? So let's get started. This is good stuff. All right, now, when we've already talked about DNA, and we know that that's where the blueprint is of who we are, why you have curly hair or brown eyes, or you can roll your tongue, right? But there's a flow, like, because I can curl my tongue, there's a protein that tells me my body to do that, to display that protein. Why I have curly hair is due to a protein. And so how do we get that protein and how do I end up with curly hair? How does it get from the nucleus to my hair? Well, this is called the flow of genetic information or the central dogma. And this is a huge portion of, there we go, of what biology is. Biology is based on this. So we go from DNA to RNA to a protein. Okay, so we have to, this is the original message. We have to write it down. So we were making the RNA, and then we have to translate it into the language of protein. So the transcription, we're writing it down from DNA to RNA, and then we have to translate this language of RNA into the language of protein so that our body knows to make curly hair, brown eyes, to roll your tongue, to make lactase, to digest the lactose from the milk that you had this morning on your cereal. So it's really important. All right. So these are the different mRNAs, or RNAs, excuse me. 8, okay. The ones that you will need to know are 2, 3, 4. Yep, that's it. Okay. These are just showing you the different ones, that how this is like a much bigger process than what we're really dealing with. But we're going to deal with mRNA, and that is the message that comes from the DNA. So we go DNA gets transcribed into mRNA. And the M stands for messenger. Okay, so you can remember that because it's bringing the message of DNA. tRNA is the one that, this is during translation, and this carries a specific amino acid. So it's like floating around, and it's carrying that amino acid. Remember, amino acids are the building blocks of proteins, right? And it's based on reading the mRNA, so the codon, and we'll get all to this, okay? And this is called transfer RNA, and because it's transferring the amino acids into a chain. And then you have rRNA, and rRNA makes up 60% of the ribosome. So this is ribosomal RNA. It's really easy to remember. This is a good short answer question, just saying. And this is where protein synthesis takes place. It's like the hub of all the activity. Now, like I said, these different ones you don't need to know, but if you're going to go into IB or AP, you will definitely need to know all 8. But for right now, you just need to know 2, 3, and 4, just those, okay? All right. Now, the genetic code is universal, meaning if I look at the DNA of a squirrel, it's going to be ATCG. If I look at the DNA of a fungi, ACTG. If I look at the DNA of a liverwort, ACTG. So everything that's living on Earth has the same genetic code. However, we have to make that into different codons or different combinations, okay? And this is when we are taking the DNA into the mRNA. And the mRNA is read in 3s. It's read in triplets. And this is called a codon. Okay? And so there are 64 different codon combinations. So you can see here, here's a codon, here's a codon, here's a codon. So this is the codon table, okay? And we'll learn how to read this. So just I know you're on the edge of your seat with excitement here. So we have to read it in threes. Otherwise, if we read it in somewhere else, it won't be correct, okay? Now it is redundant because more than one codon codes for each of the 20 amino acids. There's only 20 amino acids. So UUU is phenolphthalein and UUC is the same amino acid. Here we have UCU, UCC, UCA, UCG. That is all for serine, I believe, SER. Okay, so it's redundant. So we have more than one codon for each amino acid. Okay. All right, so how do we use this? When we start to go to our DNA code, and we'll get to that here, this is the first letter. So you start here. So this is 1. Then you go to the second letter from up here. And then, can you guess, right? The third letter is right here. So if we have a mRNA code of CAG, you go C, an A, and then G. So this would be the amino acid. If try AUG. AUG. Ooh, why is this highlighted? AUG is called a start codon. Start codon. And how you can remember what the start codon is? When do we start school? In August. How do you spell August? AUG. Boosh. Okay, so that starts it, and we'll get more into the start codon. Let's try one more. Let's do GUC. So G, U, valine. Okay. So it's super easy to use, and you'll be using this definitely. All right, so let's get into the transcription here. So first of all, the DNA unwinds inside the nucleus, okay, just like this. And we are only transcribing the gene that we need. We don't do the whole strand because we don't need all of our genes at the same time. So we're just doing what we need. So the DNA unwinds. We have RNA polymerase here. We have the free-floating nucleotides again, right? And we have the direction of synthesis is towards the opening here. And so this is making the mRNA. Remember, this is inside the nucleus, right? All right. So once we have the mRNA that we need, okay, then it's just a single strand. Then this leaves the nucleus and goes out into the cytoplasm, okay? So what happens here? So we have the DNA separates, step 1, okay? Step 2, the free-floating nucleotides are bonded with RNA polymerase, okay? The mRNA elongates in always the 5' to 3' direction, okay? But here, with DNA, right, we have A with T, C, or G with C, right? Well, here in RNA, we don't have the T. We have the U. So anytime when you have a T, it gets turned into a U when you're making the mRNA message. Okay? All right, so this is what it looks like. So mRNA gets transcribed inside the nucleus. Its message is from the DNA. It then goes outside the nuclear pore. It hits with the rRNA, right? This is rRNA, the ribosomes, and then it's read, and this is where translation takes place. Transcription is here. Translation is outside in the cytoplasm. Okay. All right. Oh, that's it. You don't need to worry about that last slide here. I got a little carried away. You don't need to know that until we get to 8.5, or excuse me, 8.6. So come with questions. Now remember, that's just transcription, and we will get right into the translation then. All right? Have a great one, and I'll see you in the lab.